Why'd I start recording before my freaking? Hello, this is. Oh shoot! All right. My name is Diego, and this is my lab 5 for Physics 2211. So just a quick agenda of the lab. We're gonna go through the purpose and introduction with the fundamental concepts that we're gonna use, the experiment itself, the results of that, and then code, and then the conclusion with what ifs. So the purpose of this lab was to measure the motion of a falling slinky and see if the bottom of it moves before the top reaches it. And so what we did to do that, um, I'll go through that in a second, but before we do that, let's talk about the important concepts behind that. So we have Newton's second law, which is force equals mass times acceleration. Drag force, which is negative b v, where b is a constant and v is a velocity vector. Gravity, which is force equals mass times gravity, the gravity acceleration. And then velocity update formula is vf is equal to vi plus f net over m delta t. So that's going to change the velocity at each certain at the final velocity if the force is consistent. And then the position update formula, which takes those v averages and the initial position of it to get you to a final position. So the experiment itself, I'll go to this one first, was to track this guy's threw a light go of a slinky from the top as it was stretched all the way toward the bottom. It was about 2 meters tall. It was 1.75 meters tall to be exact, because we used this guy's reference. And the mass of that spring was 0.218. And so what we did is he let go of it, and I tracked the bottom's motion to see what would happen. So the bottom didn't really move, as you can see here, until we reached this time step towards the right. I was kind of blocked off. But on the tracker, it looks like it was really long, but in reality, it took like 0.05 seconds to like get to that point. But the point is that it didn't move at the start. So what this is saying is that it didn't move at the start of tracking from the top. It moved once the top part reached the bottom part of the slinky. And so the coding we used for that was so we had the initial conditions, which were the mass of it, obviously. So the mass of that spring was 0.218 kilograms. The initial positions and initial velocity vectors, which are listed below, and then the time and time step you are going to be using with the constants that are involved, which is gravity's acceleration and the B magnitude for the drag force. And yeah. So to continue on with the coding, this first part is looking at when the bottom is still. So that's looking at what the net force was of the system when it was there. It's looking at the velocity when the slinky at the bottom is still there and stationary, and then what this final loop is doing, well, this whole loop, I guess, is doing is going through each time step, and it's going to change the update as you go through the loop. This other loop here, this while loop, is looking at when the bottom of the slinky does start to move. And it's going to once again track the force of gravity, the force of drag, and then add those two up to give you a net force. And then it's also going to loop through the velocities and positions as those forces change and will give you a final result. And so these are what the final results look like. So this blue one was a tracker, and GlowScript is this linear line. So it has a flat slope because it's code, and then it's gonna have a linear decline. And so as you can see, these differences are very slight. So overall, they did pretty good. But yeah. So the conclusion was that, and I guess like the human error here, this is a human error. Code does not make any errors that humans may make during an experiment. So if we go back to here, oh crap. If we go back to here, I mean, it's not shown here, but the guy was kind of holding the slinky at an angle, so it kind of looked tilted. So I think that might have messed up the experiment. But the overall conclusion was that there's tension in the spring coming from above that may be causing the spring to stay upright at the bottom until the top reaches it. So basically saying the bottom doesn't move until that top part reaches it. And so just the last like what if question, what if the slinky were released from both ends at the same time? So like if me and my friend were holding it one from the top, one from the bottom, what would happen if we let go at the same time? The top and bottom would both move inward as a slinky is a spring, and the spring wants to move back to its relaxed length, but there is still a gravity, gravity still plays a part in the system. So we'll overall move downwards, either A, once they both reach the middle, or B, as they reach the middle. Thank you.